Hello, this is MakerJan1, and today I'm going to do, well, the last run of my Stirling engine. So this is my best Stirling engine. I did a few videos a while back of it, but I just wanted to do one more run of it, and then I will be disassembling it in this video and showing you what it looks like inside, because I want to build a new Stirling engine. This one was definitely my best, maybe not in design, but in power. It produced 0.33 watts, which is my best. My other one, I think, I don't remember how much it produced, but not quite, I don't think even half that much. But yeah, so I want to take it apart and see what I can improve on in my new Stirling engine, see if the JB weld held up and all that. So yeah, I'm going to be running it, so let's start it up here. Take this out here. Oh, that's not good if I can't start the... There we go. Alright, so that might need to be a little higher there. Not sure. This might be a long video, I don't know. Almost. There we go, it's powering some LEDs too. And there's the water coming out, it's pumping. Alright, that's probably a long enough run. Just wanted to see how good it was. So it works. Alright, let's start disassembling it here. Well, let me drain the water out first. Okay. Drain all the water out of the water jacket. Okay. Now let's unstrap it from the bench here in a second. I don't really want to let it fall. Alright. Here it is. Now let's start disassembling it. So I guess we'll take the cover off here first. Let me put the camera on the tripod here. Okay. Alright, so let me take this off. Okay, so there's the So as you can see, aluminum cans are not good if you want to run it at very high temperatures. I burned holes in it, and also if the can had a very slight wrinkle in it, it would start to flap in and out from the pressure, and it would eventually wear a hole in it. So that's why there's so many patches on here. One of them was from the blowtorch, the other ones are all from it flapping in and out when it gets from the pressure. So yeah, not the best Stirling engine in that sense, but everything else was really good about it. The piston could have been a little bit longer, but it still worked quite well. So let's take the displacer piston apart here, or chamber. Alright, there we go, that's off. So it looks like the JB weld held up quite well. Looks like I did have a little bit of a kink there, which looks like it was rubbing on. There's also some JB weld down there that stuck the piston at one point. So, not the best there. Get the light over here a little bit better. So there's you can see there's a lot of wrinkles on the inside there. And that there is kind of a problem. But now let's take the piston out of here. Okay. And these bearings work very well. That's just glued right on there. Okay. And here's the piston, which worked quite well too. And that's made out of copper pipe, 3/4 inch copper pipe. And here's the other bearing there. And let's see. So now we're going to get this off. And there's the displacer piston. Looks like there's a bunch of oil and metal filings up there on top there from the oh, look at that. Look at where it was rubbing. Bunch of spots on here. So that, if it wouldn't have rubbed there, I probably would have gotten a lot more performance from this engine. I also got JB weld on there when I glued these two together. So that's not too good. But it still worked remarkably well. So there's the piston there. I'll take it apart a bit more, I guess. Oops. Connect this first. So yeah, I'm going to use some of these parts, especially this right here, the flywheel, because I don't have enough VCRs. I'm going to have to use that for my next engine that I will hopefully start soon. But it seems like aluminum cans work good for the displacers, just not the actual displacer chamber itself. It gets too hot for that. I think that might have been the screw breaking. Not sure. Maybe not. Sometimes these drywall screws break if they're in really tight. Alright, and there's the holder. I just cut that out with the jigsaw, or saber saw, that's what it's called. And there's my little manifold I made there. And lots of oil on top there. But it seems like there's still a pretty good seal here, so that's not really worn out. I might be able to reuse that, but probably not, because I'll just want to use a new one on my new engine. I don't want to risk it wearing out. I don't know if I should take the water jacket apart or not. It might be kind of hard to get it apart. Oh no, I could just pull the can out of here. See if it's rusting inside the water jacket there. Not really, a little bit. But it seems like the water jacket held up pretty well. A little bit at the bottom there where water would have been sitting when it wasn't running. But, yeah. Altogether, this was a pretty good engine. Except for the main problem. That was just not the best choice to use aluminum cans for that part. But that works really good. So yeah, my next engine, I'm definitely going to use these for the displacer chamber, and I will be using my cans here. Actually, my cans are here. I forget where my cans are. Whatever. But yeah, I have aluminum cans that fit perfectly inside of there. So yeah. Still haven't figured out how I'm going to connect the two whipped cream cans together, but I'll figure that out. And I don't know if I'm actually going to use the same wood structure or not. I might have to rebuild it, because the water jacket, this part here, at least I'll have to rebuild this part, because the water jacket's going to have to be a good bit bigger than this. So, unless I could possibly reuse this water jacket, because it's just a little bit bigger. So it might work, I don't know. But anyway, that was the disassembly and last run of this engine. One of my best engines, definitely. So yeah, I hope you enjoyed that. Yeah, don't use aluminum cans if you're going to, yeah, they're just too weak and melt at too low of a temperature. But yeah, you can see there's a bunch of spots in there where it was rubbing quite a lot. So yeah, thanks for watching. Hope you enjoyed this. Bye.